Alright, hi, I'm Mattan, and this is my FRQ video project. Mine is on the 2016 Calc BC question 6 of the FRQ, and so let's get started. So first, it's asking to write the first four non-zero terms in the general term of the Taylor series for f about x equals 1. So right here, we can already see it gives us the first two coefficients, and here it gives us the equation to find the rest. So I'm going to make a table here, and here I'm gonna write f of 1, and assuming the first four are non-zero, it'll just be f of 1, f prime of 1, f prime of 1, and f triple prime of 1. So first one is just 1, second one is also given, and it is negative 1/2. Third one we have to plug into the equation at the top, so it's f prime prime of 1 equals 1 times 1 factorial, which is just 1 over 4. So f prime prime of 1 equals 1 over 4. And then here, f prime 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 of 1, if I plug that into this equation again, it'll be equals negative 1 times 2 over 8, which equals negative 1 over 4. So these are our first four coefficients, and then using that, we know the formula for Taylor series is this right here. So it's going to be f to the n of c times x minus c to the n over n factorial. So that's going to be pretty easy to do, and then it's obviously going to be like that. But here, so we know the first term is going to be to 0 because it's just f. So it's going to be 1 over factorial 0 times x minus c to the 0. And then it's going to be minus 1 over 2 over 1 factorial times x minus c to the 1 plus 1 over 4 over 2 factorial times x minus c squared minus 1 over 4 3 factorial x minus c cubed. And then along with that, it'll be the general term. I just ran out of room, so I'm going to do it down here. I'm going to simplify everything, so it's going to be 1 minus 1 over 2 x minus c plus 1 over 8 x minus c squared minus 1 over 24 cubed and plus dot dot dot. General term, I'm going to simplify down here because you can simplify this one. So we know the equation is negative 1 n times n minus 1 factorial over 2n. Or 2 to the n, my bad. Oops, I just messed everything up. Okay. And then all of that times x minus c to the n over n factorial. So then this can cancel out, and this cancels out. This becomes n. So then the equation is just negative 1 to the n times x minus c to the n over 2 to the n times n. And I'm going to put that here for the general term. So that's negative 1 to the n x minus c to the n over 2n times n dot dot dot. Kind of ran out of space here. Oh, never mind, we're good again. So yeah, that's part A. Okay, so for part B of this question, this is a pretty easy one. We're given the center and the radius already. So what we have to solve for are just the edges of the interval. So since it's centered at 1, if it'll work, oops. Okay, so since it's centered at 1, we know that x minus 1 can go to 2, and we haven't tested these limits yet, right? So we'll add 1 here, 1 here, 1 here. So we know that the interval is from negative 1 to 3, and so what we have to do is we need to take our equation of the Taylor series from before, which, if we see if I can remember, is negative 1 to the n times x minus c to the n over 2 to the n times n. And Yeah, that looks right. So I can change C right here to 1. So now what we have to do is we plug in the 3 and the 1 as x values here, and then we need to test these series for convergence. So because we know like within those two numbers everything is gonna be nice and convergent, but we have to test those. So let's start with -1. So integral of n equals 0. Infinity -1 to the n minus 2 to the n over 2 to the n times n. So here, if we can see, it just becomes -1 to the n times -1 to the n. So these will cancel out, and then it'll be 2 over 2 to the n, which just becomes 1, which is useless to us, and that's over n. So then this cancels out. This will just become series 1 over n, and we know that's a harmonic series, so it diverges by harmonic series because 1 over n is always divergent. So we know that it's a closed interval on this side, and then on the other side for 3 or -1. So here, same thing, -1 to the n. And then here it becomes 2 to the n over 2 to the n. Those cancel out. And here it's a little different because there's that negative that makes it an alternating series. And for an alternate series to be convergent, all that needs to occur is the limit as n approaches to infinity of a to the n, which in this case is 1 over n, needs to be approaching 0, which in this case it does. So here it's 3 works because the series is convergent. If you want to be fancy, you can say it's conditionally convergent by the alternating series test, and that's all you need to do for B. So it's from -1 to 3, and that's it. Okay, so for part C, even though it might look a bit confusing, or at least it confused me at first, but if you look at it, it says the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternate series. Use the first 3 non-zero terms of the alternating series to approximate f of 1.2. Now, if we look, I just pulled this back from the previous, I think this was question 1. So here we wrote the first 4 non-zero terms along with the general term. So pretty much all it's asking us to do, wait, this should be, oops, this should be 1 right here, and same with here. Same with here, because that's already given. Same with here. So I don't know what I was doing before, but so pretty much all we have to do is plug in 1.2 for x. So here it's 1 minus 1 over 2 times 0.2 plus 1 times 0.2 squared over 8 minus 0.2. Not even cubed. We don't even need that. It's only first 3 non-zero terms. Alright, whatever. I guess that's gone. My bad. It's a bit sloppy, but pretty much you just have to plug in 0.2 for all that, and you can calculate it. It's 1, for me to calculate, it's 1 minus 1.1 plus 0.005, which equals 0.905. And surprisingly, that's all the guidelines are asking for part C. So that one's pretty simple. It's a bit deceiving, but that's really all you need. Okay, so for part D of this problem, it's just asking us to show that the approximation found in part C is within 0.001 of the exact value of f of 1.2. So pretty much what it's asking is, so error is the absolute value of f of 1.2 minus our approximation, which was, I believe, 3 terms. So it would be like that, which is also f of 1.2 minus 0.5. Pretty much we just need to prove that that is less than 0.001 or within that much of the exact value. So pretty much one of the rules when solving for this error is that terms of the series, if they alternate, they must decrease in magnitude, which here we can see that they do. And terms of series So they alternate. They decrease in magnitude. So we can see that it's slowly becoming less and less of a change in magnitude. And they also must limit to 0. So since all of that is met, we can use this. And pretty much what this states is that the magnitude of this must be at most that of the next term left off. And since here we used these, damn, it keeps changing back. But since we use these first 3 terms right here, the 4th term, which is left off, would be at most the error of this right here. So pretty much all we need to do is we need to plug 1.2 in for x for that, which is just absolute value of negative 1 over 24 times 0.2 cubed. And that is just 1 over 24 times 1 over 5 cubed, which I believe is 1 over 3,000. And since this right here, since the error of this, or the error of the approximation must be at most 1 over 3,000 as stated here, we know that 3,000 is obviously less than 1 over 1,000, and therefore it's within 0.001, the exact value. And that's it. Thank you guys for listening, and I hope this helped you. And I have more resources linked down below if that was confusing. Bye bye.